Let us denote the kinetic energy of a moving clay block with a function with parameters m and v, where m is the mass of the block and v is the velocity. The basis of this thought experiment involves launching clay blocks against a wall and allowing all the initial kinetic energy to be converted into heat energy. First, we will establish the proportionality of mass with kinetic energy. So, we send a clay block bolting into a wall. Once it collides, the clay block stops moving, implying that the heat produced in the deformation of the clay block equals to the kinetic energy before the collision. Now, if we stuck two similar blocks together, side by side, and send them towards their impending disfigurement, we will get twice the heat energy. This means that twice the mass, twice the Ke. Hence, we have established that mass is proportional to kinetic energy. We can now write the function as this. Next, we shall now establish the proportionality of velocity with kinetic energy. We do this by slamming two clay blocks of mass m together. Each block will act as the wall for the other, and both blocks will cancel out each other's momentum, resulting in a final velocity of 0. The total heat generated would equal to 2m times the energy function of V. Now we picture two fresh new clay blocks, one of which is stationary, and the other traveling at the speed of 2v towards the stationary guy. Observing the changes in momentum upon impact, the blob of clay of 2m will have a velocity of v and a final kinetic energy of 2m times the energy function of v. But what was the initial kinetic energy of the moving blob? It would be this. And what about the heat generated from the collision? That would be this. This is because the relative speed between the two blocks of clays in both experiments are 2v. So the same amount of heat energy is being released. And so the initial kinetic energy would equal to the heat release plus the final kinetic energy, which shows that kinetic energy is proportional to the square of velocity. Scientists in the 19th century also used clay to determine the relationship of V and Ke. Balls were dropped from different heights onto soft clay, which created indentations in the clay. It was shown that twice the impact speed would produce an indentation 4 times deeper.